Let's start to set up the Talon side. So you're going to want to grab the Parrot example.zip from the Talon Slack workspace. In the beta channel, there's a pinned message which has a link to the Parrot example.zip download. I've downloaded that here. Let's double click to unzip it. And as you can see here, it has this code. Okay. Now this Parrot integration.py is sort of the guts of it. And then we're going to define our patterns.json, which tells Talon what patterns to use. Let's copy a link to this folder so we can get it into a terminal. I'm holding Option here to copy as path name. Nice little trick. Let's switch to VS Code. Okay, so you can see here I'm in my Knaus Talon fork. This is actually just a vanilla Knaus to make things easier for you. And so you can see here, this is Knaus so what we can do is, so let's ls the directory that I copied. So there's Parrot examples, right? Let's look at that as a tree. Okay, and so this is user. So let's make a directory called plugin/Parrot. Okay, and let's go ahead and move everything from Parrot example/user/star into plugin/Parrot. I don't need those single quotes. Okay. And so now we have both of those things in there. Let's go ahead and open these up, see what they look like. All right, Parrot integration.talon, kind of a big file. You can basically just ignore everything in there, I think. Over here, let's look at this. Okay, and so you can see this is an example of what you would do. Let's now, so these patterns.json, you're going to also want to move those into your Parrot integration as well. So let's move Parrot example/Parrot/patterns there as well. Okay. Let's list it. So these are the two files that you're going to be interested in. Notice there was this model.pickle. We're going to use our own trained model for that, okay? So on the left-hand side, these are the patterns.json, right? These are going to be the actual names that we put when we were training, right? So it was alveolar click. And that's the only one that we're using, right? So let's call that, fine, cluck is reasonable enough. You're going to want to use a throttle here. You want to throttle itself. The thing is, Parrot splits it up into frames, right? So it might tell you that the sound triggered 10 times when you make a single version of sound. When I just go, right? That triggered like 10 frames. So we want to say throttle. This is 120 milliseconds. So when it hears it, it's not going to try to hear it again for 120 milliseconds. 120 milliseconds is pretty reasonable. We don't need to throttle pop because we don't have pop. So let's get rid of all of these. Okay. So by the way, I'm doing all this by keyboard because if I had Talon on right now, then every time I popped, it would start listening, and that would be really annoying. So I'm just going to do this stuff by keyboard. Okay, so you can see one thing to note, this power threshold is not the same as the power threshold used by Parrot. Hopefully someone will fix that someday. But until that day, you're going to need to get intuition for what this power threshold is, okay? And we're going to do some experiments to get intuition for it. Okay, so this, I believe, is a working setup. For what it's worth, for probability, I tend to go way higher than this. So I'm usually running with multiple nines, right? So I'll be like 9999, something like that. We can start with something lower and do some experiments, okay? All right, so then on the other side here, so Parrot cluck, print cluck. That's great. That's how you want to start, okay? So let's see how training's going. Okay, this is pretty good accuracy. Generally, if it's punching above 96, I'm pretty happy. So, you know, you can let it finish in case so let's see, is the loss still going down? Not really. The loss seems to be bouncing around. That happens with machine learning. Sometimes it'll bounce around on a plateau and then drop again. And in the future, Chaos Parrot may implement learning schedules and stuff like that. But so don't necessarily just kill it if it's stagnant like this. But for the purpose of this video, I'm gonna go ahead and do that. So let's just Control C and kill this thing. I think it should be fine because it takes checkpoints. Yeah, so as you can see, there's a checkpoint of the best thing, okay? That's our model. So let's go ahead and copy that. So let's move that, right? Data / models / my blah, blah, blah. Okay, let's copy it, right? I'm going to copy this to where I'm keeping my Knaus.j repo. I have it linked into user, but let's just copy it in here. And it was plugin / Parrot. And yeah, great. Okay, and let's I tend to, when it's actually here, just use like model.pickle. Just so that I don't need to change the thing that references it. So, in the actual Parrot training directory, I'll use this. But then when I move it into my actual Talon user files, I just always put it in the same place. Okay, great. So let's go back to this other file, this parrot integration.py. I think the only things you need to touch are these. And as you can see, yeah, okay, so this isn't quite right. It's not Talon home / Parrot. Oh, interesting. Okay, so it looks like they want you to put the Parrot stuff directly into your Talon home / Parrot. That's where it wants the patterns.json and the model to go. That's not what I'm doing. So you can do that if you want. I'm doing this, so it's going to be like /user / Knaus.j Talon / plugin / Parrot. Okay, cool. So now that's where the pattern is. That's where the model is. In theory, we should have a working classifier. Okay, and I like to, instead of printing, I like to use app.notify because that'll do a pop-up. Although if I'm recording a video, that may not come up. So let's just leave it how it was. But yeah, keep in mind app.notify. That's the way that you'll do it, because then you'll be able to see the toast come out on the top right. So we do print. Okay, welcome back. Talon open log. Sleep all. Okay, so here's the log. And in theory, when I start making popping noises, you should see something in here saying that it heard a pop. Welcome back. Okay, so nothing happened. So when you get into trouble, you want to open up your Parrot integration file, and you can set debug to true here. Let's see if that helps us. Okay, cool. What if I get rid of this debug true? Okay. Seems to only work with debug true. I wonder if I have debug true on my regular setup. Huh, I do. Okay. So if you're having trouble, maybe just leave debug true on. It doesn't seem to do much bad. So with debug true on, every time I make a noise, it prints out cluck. Cool, right? And as you can see, it's not perfect. You saw like when I was doing some speech, like when I was speaking earlier, the noise came out once or twice. Yep, there we go. So you can see it popped out there. Now what we can do is we want to kind of see what power threshold, what power Talon is hearing, what probabilities it's hearing, and that's going to help us do our tuning, okay? So the way we do that is we need to do events.tail in a Talon REPL. Welcome back. Talon open REPL. Sleep all. Okay, so here we do events.tail. Okay, and you can see we're getting spammed with Parrot stuff. I think that's what debug true does, is it does this output. So if you're using events.tail regularly, you probably don't want to leave debug true on. But you can see here, right, it's quite confident that I'm speaking when I'm speaking, which is cool. So you can see these probabilities here. Now let's start making the noise. Okay, so notice that we actually, like, so this is why I say I tend to use such high probabilities, because you can see here, it's like 99.99% confident in these, right? So if we want to reduce some of those false positives, where you can see here, notice it was thinking I'm saying cluck when I'm speaking and random things, we want to get rid of those, right? So here's how it works, right? If you're getting false positives, which means it's hearing the noise when you don't want it to, then you want to increase the probability threshold. So in this case, it's 0.87. We can do way better. Let's do 0.99 and see what happens. And I think it might auto reload. I'm not sure. Yep. Yeah. See, it does auto reload. Okay. So now, as you can see, we're not getting, like, you know, I'm making all these, I'm talking, I'm speaking, and I'm not getting any of these clucks. And now when I do, notice I'm still getting them, right? If you find that you're getting false negatives, right, which means that you're making the noise, but Talon's not hearing it, then you want to go ahead and drop that threshold. It's intuitive, but you might not think of it. You can also mess with the power threshold. Generally, you can kind of see when you're making the noise. So let's see, I'm making the noise, and you can see the power. Yeah, I mean, I don't know, 20, let's see. So I could probably go a bit higher, but you know, I'm not getting a lot of false positives, so I may leave it for now. So generally what I'll do, right, when I first introduce a sound is I will just map the sound to just that app.notify thing so that the toast comes up every time Talon hears the sound. And then I will just, that's how I'll start. And for like a day, I will just have that sound, only do that. And that gives me a sense of how many false positives, false negatives I'm getting out of Talon, right? So so you can see here, I would have gotten 2 toasts there, right? And so I'm like, okay, I either need to, so you can go and see here. This is easier when you're not also speaking because your output doesn't get spam. But okay, you can see here, you're going to get a message like this when it actually fired. And so this will tell you, okay, and if you know this was a false positive, right, as you know, the last one was a false positive, we can say, all right, what was the probability It was 995. What was the power is 94. Okay, so power is not going to help us here because that's a very high power. But looks like if we up the threshold to 999, then we wouldn't have gotten one there. So let's try that. That's our new threshold. That might be too high, but we can mess around and see what happens. That's still pretty reliable. So as you can see, that we're able to get away with that threshold, it seems like, and now hopefully we'll get fewer false positives, right? So basically you just kind of, go about your day for a day using Talon, hearing what background noises come, and the toast will pop up when Talon hears the noise, and then you'll periodically make the noise, see if the toast pops up when you make it, and then you're just going to kind of tune the thresholds as you go. And then, as I mentioned earlier, if you find that there's a certain noise that is commonly triggering that sound, then what you can do is just go and record, like go back to the terminal where you're recording noises, run Parrot again, and go through the same recording process to record a background noise, right? You say here, background, make sure you use the exact same name, okay? There would be better if there was a picker, but there's not. So you do that and you go through the process, you record a few more, and you record the noise, right? And this is an iterative process. It'll take you 1 or 2 iterations. You'll get a new model with a different name. So basically you go through, you record, you do a recording, right? So let's say I found some new noise that's problematic. Then, all right, let's use that same background threshold. And let's say someone was snapping in the background and that triggered it. Okay, so let's go ahead and trigger that. Okay, so now we've recorded that, and then we just use L to go and retrain it. And it's slightly annoying. You're going to have to go through and answer all these things again. You just say yes, and then the model name, we'll say like my model, I don't remember what it was, and now it'll be like, if it's not a different day, you can just say like, new, whatever. Anyways, you use a new name. And then we use AudioNet 5. You can use like bash expect, Google it, if you want to automate some of this. Okay, yes, background, yes, alveolar, yes, speech. And it's going to go ahead and train it again, right? And so you wait for that to go through like we did before, and then you just copy that over the top of the old model.pickle, and now you have a new model. I recommend either checking your model into Git along with your patterns file and everything else, or using something like DVC if you don't like checking big things into your repos. So great, you can see it's training. Let's kill that because we're not actually training a new model right now. So that's sort of how it works. And then the last step is basically to, so we now have a fully functional Parrot setup. It's let's say a day has gone by and we're happy with the accuracy of this sound. It's triggering every time we want, like almost every time we want it to, not triggering when we don't want it to. And as you can see, that wasn't too hard with this one. There's been no false positives, it looks like, since I upped that threshold, and I can still hit it super reliably, right? That didn't take very long. It happens to be a good sound, right? So I picked a good sound. Other sounds might not work as well. I find, for me at least, works quite well, and also works quite well. But other sounds might work as well, what might work well for you as well. So then the last step is to just map this to do what you want it to. That's going to really vary, but let's say we wanted to map it to wake and repeat, which is what I have set up. So basically what you can do is we can go and just look for wake and sleep.talon, right? And you can see there's this welcome back thing, right? So when you say here, so we can just drop this directly in here, right? And we could just get rid of welcome back altogether and then just say Parrot cluck. Sleep all. There we go. Or you can copy that block and just do parrot cluck or whatever. So now we've taken Knaus J and made it so that we can pop to wake it. If you also want to do a repeater noise, right? So let's look in repeat. So this is, so I like to use repeat phrase so that if I have a big phrase like, you know, take pit word hello, and I want to then repeat that, I like to use repeat phrase. So right, so then we can just say parrot cluck. Notice this is mode all, so it's like it works while you're sleeping. Here we probably want this not to be mode all. We probably want mode sleep, to be honest. Yeah, so let's do this mode sleep. Sleep all. Notice how quick it is to turn on, right? Versus welcome back, which takes a little time. Okay, so we now have that set up. And now so by default, this has no context at the top, which means that it's always on. So parrot cluck, and we want core.repeat phrase 1, I believe. So let's try this. Go up. Sleep all. Obviously, if you spell repeat the old-fashioned way, it doesn't work. Go up. Drowse. Sleep all. So because it's repeat phrase, it's almost like making little macros. So I can chain things and then pop to repeat it. Word hello, go up. And that's it. If you want to train a new noise, you can just go through the process, add a noise, and then you can use it along with the other noises. You may need to tweak your threshold. So every time you retrain your model, it's possible you need to tweak the threshold, right? So if you add a new noise, you might need to decrease the confidence thresholds for some of the other noises. It's sort of a working process, and you'll iterate a couple times, and then you'll have something stable for a while, and then you'll get excited, iterate again. Hopefully this was helpful. Thank you so much for watching, and don't forget to like, subscribe, and consider sponsoring me if you find these videos helpful. Happy coding.